Good evening, everyone, and welcome to day 11 of Great Amrita Alumni Conclave on Advancement in Construction Industry. Amrita Alumni Conclave is a full-fledged virtual webinar series spearheaded by the shining alumni of Amrita. And these sessions are planned for every engineering aspirant to gather valuable information on all aspects of engineering and to get to know the futuristic scope within various streams of engineering. Today, we have with us Mr. Kailash S. Senior Engineer L&T Construction. Uh, he have completed his civil engineering from Amrita School of Engineering in the year 2019. And we also have Mr. Navaneeth. He also completed civil engineering from Amrita School of Engineering in 2019. Now, I would like to welcome Kailash to take up the session forward.
Thank you, ma'am, for giving an introduction. So I am Kailash. So currently I'm senior engineer in Buildings and Factories IC of L&T Construction. To give initially a background of my education and career path, as ma'am said, I did my BTech from Amrita School of Engineering. I'm of the 2015-19 batch. Firstly, I thank the management of Amrita for giving me this opportunity to give a talk in this alumni conclave to students. And then I'm also thankful that I studied in Amrita, which helped in transforming me into an engineer from a 12th standard pass out student, right? So initially, after my BTech, I was placed in L&T through the campus placement of Amrita, and I worked for the Buildings and Factories IC for a brief period of 2 years. So now I'm senior engineer planning. I was posted in the site of IIT Hyderabad campus development project, where I was looking after procurement. So now currently I'm doing my MTech in construction technology and management in NIT Trichy through L&T's Build India scholarship program. So currently I have completed my first semester of my MTech and I have stepped into my second semester. So now we are going to myself and Navaneeth. We both were classmates in Amrita and now we are colleagues at L&T. So now I will be speaking on the topics of 3D concrete printing and building information modeling. So I'll be touching small parts, and I'm well aware that the participants of this session are 10th, 11th grade students and 12th grade students who are going to give their board examination and will be stepping into college in few months. So, but you will not be familiar with the civil engineering terms. In order to understand the advancements in construction industry, you need to know some basic terms so that you will be able to understand how the advancements are there in this construction industry. So to start with, in the left of the presentation, you can see an image which shows a building with a foundation which carries the load of the building above it and transfers it to the soil. And then you have the ground floor, you have a ground floor grade slab, then you have columns, you have beam, you have the first floor slab and roof slab. So this basically how you picturize a normal building. Then on the right hand side you have the drawing. Basically it is a plan and an elevation. Plan basically shows where your different rooms are located, different doors, utilities are located, and the elevation shows how your building looks when you're standing in front of the building and looking at it, right? So coming into 3D printing of concrete, you need to know what is a concrete first in order to know what is 3D printing of concrete. What you can see on the right hand side top is concrete, which most of you would have seen while you're traveling in almost all construction sites. You would have seen concrete, which is gray and black in color, which has rocks. To describe it in a crude manner, it has rocks, soil and cement. So concrete is basically a mixture of cement, sand and coarse aggregate and water. Coarse aggregate is basically, to tell it in a crude way, these are rocks above 4.75 mm. So what happens is, in a concrete, cement performs the function of binding the coarse aggregate and sand and keeping it in position. What happens is cement reacts with water, an exothermic reaction happens and then it solidifies, a hydrated product is formed which keeps the sand and the coarse aggregate intact in position. So now how do they mix this concrete and lay it inside? In the top sorry, in the bottom right, you can see a concrete mixer, which most of you would have seen. Basically, laborers put the coarse aggregate, sand and cement and water, and then mix it, and then take it to the site and lay it inside. This you can see in the small construction site. Basically, if you go to large construction sites like which L&T works for, you would have seen what is in the top left corner. You can see this batching plant where you'll have silos for storing your cement and fly ash and different compartments for storing your coarse aggregate and sand. And then you'll have the batching plant mixing the concrete in the set proportions which are told by the engineer, and then it loads it onto the transit mixer. So then you can see on the right side, which is a transit mixer, the role of it is to transport the concrete from the batching plant to the site where you're going to lay it. Depending upon the accessibility of the location where you're going to lay, either you're going to lay it directly using manual labor or using boom placers or using a tower crane as shown in this picture and a bucket. So ultimately you're going to place this concrete in the location where you've already tied your metal reinforcements. So now this is the conventional method of concreting, right? So now coming into 3D concreting, which is the advancement in our construction industry. So how is it different? So now I'm showing some images of buildings which are similar to the normal conventional buildings. You cannot figure out any difference, right? But actually these are all 3D printed buildings, either which were done cast in situ or the modules were printed in a different site and then brought to the site and assembled. So entering into the topic of 3D printing of concrete, firstly we'll see what is 3D printing. 3D printing is basically additive manufacturing process where we build and deposit layers of material to create a three-dimensional part. So this is exactly the opposite of the subtractive manufacturing process which we usually follow. You can see on the bottom left, in order to obtain this material from this solid block, what we do is we cut this portion to obtain this part. This is the subtractive process. Against this, in the 3D printing process, what we do is we deposit layer by layer in the desired location where only we require the material to be deposited. So ultimately, there is less material wastage in 3D printing. So this is general 3D printing in various industries. Now 3D printing is extensively used in the medical industry. Now why 3D printing in the construction industry? Because we have been using the conventional method of concreting for so many years, and how 3D printing is helping or is going to help the construction industry. First is the reduction in construction time, because by printing what we do is we are mechanizing the process. Your machines or robots are going to print the materials for you. So what happens is, of course, when there is less of human intervention, there's going to be reduction in construction time. So next, because of the less human intervention, there is less labor involved, so there is reduction in labor cost. Then thirdly, it is formwork free. Many of you might be thinking, what is formwork? Because formwork is a civil engineering terminology. So what you can see in the left hand side image, basically there is a footing and then you can see there is a wall where you can see metal rebars being tied and laborers have poured in concrete. Basically concrete in its fresh stage is semi-solid or semi-fluid. Once the reaction commences, after a certain period of time when the reaction is complete, you get a solidified concrete, right? Until it is solidified, you need to keep the concrete in position so that it can acquire that shape. So we keep these metal shutters or wooden shutters to keep the concrete intact in its position until it is cured or set. This is called the formwork. Basically, because in 3D printing, what we are doing is we are depositing it layer by layer. I'll just show you an image. So this is basically a 3D printing of concrete. You have a nozzle which is printing or depositing the concrete in a layer in a predetermined path. So what happens is, because you are printing it layer by layer, there is complete elimination of formwork. And in the regular concrete production, concrete construction, usually 30% of the cost goes to formwork and 60% of the time is consumed in shuttering and deshuttering of the formwork. This is completely eliminated in case of 3D printing. Next, coming to the most advantage part is that it gives you the geometric and design flexibility of building complex structures which we cannot attain using the conventional method of concreting. So now let's see the process involved in 3D printing of concrete. Initially what we'll have to do is create a three-dimensional model. We all know for a building of buildings, initially what we do is conceptualize and then make it into 2D drawings. What we have is a plan, then you have elevation, and you cut the plan into several sections and show. But the first step process for 3D printing is you need to have a three-dimensional model of the building or the part you will have to produce using 3D printing. We create the 3D model and then we slice the 3D model into several layers with thickness equal to the layers of the deposition thickness. So we divide the building into slices, and then the path the nozzle has to follow is predetermined and it is fed into the machine, and then the 3D printing happens. After you print the concrete, post-processing like curing and then grinding if necessary are done, and then you get the final product. So this is the image which we have already seen, where the nozzle follows a predetermined path set by the machine and then it deposits it layer by layer. So there are different techniques for concrete printing. Basically, the main is the extrusion-based 3D printing system, which can be done by two ways. One is frame-based using a gantry, which is shown on the left-hand side, and robotic arm-based, which is shown on the right-hand side. So frame-based gantry system is basically you have the nozzle which sits on a gantry which moves on the frame, and it moves on the path and deposits the concrete. In the robotic arm-based system, you have a robot or machine sitting in one corner, and it has its arm which can move about different positions and deposit the concrete. So coming to the types in 3D printing, as I said earlier, either you can have the machine directly in the site printing your entire building, or you can divide your building into several modules, and these modules can be printed at sophisticated large factories where you have place. You can 3D print these modules and then transport it to site and then assemble it and grout them. So now coming, any new advancement will have its challenges for implementation. Now we'll see the challenges in 3D printing of concrete. First of all, the main challenge is the creating the niche design. Basically, a concrete niche design is the most important part of any concreting purpose, because the strength of the concrete is dependent on the niche design. We need to be able to print concrete with coarse aggregate. Whatever project which have been done till now, about more than 99% of them are done using only fine aggregate, which is sand, because you need to have the coarse aggregate coming out of a nozzle. Nowadays, because of COVID, we are familiar using hand sanitizers and hand washes, right? We have a nozzle through which once we press through the nozzle comes out the sanitizer or the hand wash. Similarly, you need to have concrete coming out of a nozzle when the nozzle is moving around and deposits. When you have coarse aggregate, that is rocks which are of larger size, it's going to be difficult to make it come out of the nozzle. Second is reinforcement printable concrete. Because all the projects which we have done using 3D printing of concrete, we use only aggregate in the concrete. We are not using reinforced cement concrete, because while you are printing, you cannot print the reinforcement, that is metal also cannot be printed along with it, because the fluid to solid transition and the solid to fluid transition of metal is at a higher temperature, which cannot be achieved at the same time. Then comes the prediction of deformation of the layers and the shape retention. Once you are laying a first layer of concrete, and then when the nozzle is ready to print the second layer, the first layer should have strength to hold the weight of the second layer as well as hold the structural load. So these are the main challenges. And what are the important parameters which we need to consider when we go into 3D printing of concrete is the buildability and extrudability. Buildability is basically the layers should be able to hold the weight of the upcoming layers which are to be deposited, and extrudability is that it should be workable enough in order to be able to extrude it or make it come out of the nozzle. So that's what is said in the second point also. The deposition of upper layers should happen without deformation of the lower layers. So the lower layers should have a shorter setting time. That is, it should gain the early strength in order to sustain the loads of the upper layers. So coming again with the challenges while printing concrete, these are all challenges generally in 3D printing of concrete. Coming to challenges while we are printing the concrete, While we are printing the concrete, we need to know what is the strength attained by the lower layers. We need to ascertain whether the below layers will be able to hold the layer of the upper layer. Because concrete is basically not a manufactured product. You have sand, aggregate, which are all natural, derived from natural products. The strength is going to vary. So you need to know, you need to have a non-destructive methods of assessment to know whether the strength is attained in the lower layers to sustain the loads of the upper layers. Then comes the geometric deviations. What happens is, if there is a deviation in the printing of the first layer, it keeps on compounding as the second, third layers keep on printing on the layer after layer. You will have the deviation compounding, and it will, what if you are planning for a straight building, what happens, you might have a tilted building while you are printing. So you need to have a feedback mechanism by which the deviations is learnt by the machine and it is corrected by the upcoming layers. So now I'm just showing you some of the failures which we'll observe while doing 3D printing of concrete. So you'll have slipping of layers of concrete as shown in the image, first image, where there is no sufficient adhesion between the layers of the concrete. So the one entire layer is slipping off from the below layers. And in the second image, you can see there is too much of water introduced in the hose, so there is a flow of the concrete and it's not staying in position. Thirdly, you can see there is extra deposition of layer or extra deposition of concrete at a single location. This is because ultimately after printing a single layer, what happens is the nozzle increases its height to start printing the second layer. Due to gravity at that time, certain amount of extra concrete is being deposited at that single position, so you'll have extra deposition at one particular location. Then you have variation in thickness of layers. The thickness of the layer in the bottom are not uniform, because of which the structure has tilted. So now we are seeing the some of the 3D printed concrete buildings which was done by L&T. This was a single story building done in the year 2019 November, and this is a two-story building which was done in December 2020 with reinforcement. That is, reinforcement was not 3D printed, reinforcement was laid and 3D printing of the concreting was done. So this is for about 3D printing of concrete. Coming to our next topic, which is building information modeling. So by building information modeling, what we say is, or crudely people understand, is just a three-dimensional model. But building information modeling is not just a three-dimensional model, but it is a three-dimensional model which has information into it. So we have 2D softwares, we have CAD, AutoCAD, where we do two-dimensional plan drawings, sections and elevations. What are the basic elements in these drawings are usually just lines. But in a BIM model, the basic building elements are the building elements itself. You don't draw it as lines. If you are drawing a wall, you draw a building element as a wall. Information can be tagged to each element. Like if you are just considering this image you have, if you're going to construct a wall in this place, you can have details like the material specification, whether the wall is going to be of a solid block or a AAC block, or is going to be a concrete wall, what is the cement plaster thickness which is going to be placed above it, what is the texture of finish, and what's the paint shade which can be added into the building element, so that you get all the information. The major advantage of having a BIM model is you get detail of quantity estimation. There is a separate department of quantity surveying in almost all construction companies to calculate the quantity of different materials, which will help them for scheduling and procurement activities. Basically, when you are tagging the information into the model at the initial design stages itself, you get to know the quantity at a click of a button. So coming to BIM in the construction project, it basically helps in 4 stages of a construction project. Basically, it is throughout the lifetime of the project. First is in the design stage, where you initialize the concept of building a the purpose, and the architects and engineers come together and work on a model. Here what happens is everyone is working on a single model. Everyone collaborate and work on a single model rather than working on different models and then collaborating. So what happens is there is better coordination between the different departments. Secondly, during workflow planning, In order to, as I said earlier, you can have the estimates of quantity and various other information at a single click of a button. You need not have a separate department of quantity surveying who sit and calculate the entire quantity and so on and so forth. Thirdly, during construction. During construction, it helps mainly in project monitoring. What happens usually in project monitoring is different people under various stages update to their bosses at a different time. What happens is a concrete might not have happened at that location, a foundation might have not been completed, but the site engineer says that work is completed, being afraid that the superior might scold. So what happens, the boss will tell to his boss that this foundation is completed. So what happens is ultimately a wrong information is being passed on. What happens when you're doing a project monitoring using a BIM model? This BIM model is available with everyone, right? With the site engineer to the construction manager to project manager, director and cluster project manager and higher up the organization. Everyone has this access of this building model. So in real time, you can upload the changes and the project progress. And lastly, for operation, like you're handing over the building after completion of a project, you're handing over the BIM model, which is similar to how we hand over the as-built drawings of any building after completing the construction. So this BIM model will enable the client to have better understanding of how their building is constructed and which will help them when they are looking for options of renovation or repair works in the future. So coming to the main advantages of BIM, that is building information modeling, is the main three C's. First is the collaboration. Basically, when a construction project is there, there is collaboration needed between the structural engineers, architects, consultant, client, and the execution contractor. What happens is everyone is working on the same model. So there is better collaboration between different. So when an architect is making a change, he wants a different size of dimension of the pillar or the beam. It directly is conveyed to the structural engineer at the same time. Secondly is the coordination between different disciplines. If you see in any construction site, there is always a fight between the MEP and civil people. That is, MEP is mechanical and electrical and plumbing, and then civil is people who take care of the structural and the finishes activities. So what happens is there will be sometimes services which are going, that is electrical services, for which the structural people might have not given provision, they would have not given a cutout. Then on later stage, when the MEP people come and tell that we need a provision here, they start doing core cutting and then they break the walls. This all leads to additional costs which are unnecessary. This can be easily avoided because of this better coordination when everyone is working on a same model. Thirdly is communication. Communication between different stakeholders, that is the client, consultant, everyone are on the same page because the model is exactly depicting what is being done on site and what is required. Coming furthermore, adding to the advantages, so initially you can detect the problems at an early stage. What happens is MEP services are there and the structural columns are there. For an example, I'm saying if there is a structural column and you have a plumbing line coming, if that is going to cross into a column, you cannot allow that, right? Either you'll have to reroute your plumbing or you'll have to move the structural element. But usually moving the structural element is not going to be possible because it's going to ultimately affect the entire design of the building. So you'll have to reroute the service. Or what happens if the service is laid out before the structural column is being raised? Then you'll have to cut the service and then again reworks happen. So when you're designing itself, you get to know where all the clashes might happen and you can detect them. Second is the updation or change made is universal. Because you're working on a single model, a change made in a single place is universal and is a change made everywhere. So everyone can access that information. Thirdly, as I told earlier, it helps in easy project monitoring and control and improves scheduling by giving an effective and efficient way by giving more information on tasks. You get, like, for example, if you know, to explain it more easily, let me give an example. For example, if you have a 5-story building and you want to erect a facade or a window, which is made of aluminum and DGU, double glazed unit, which is very heavy. So if you need to plan well beforehand. You want to schedule the activity. You need to know the weight of the material. You need to know the height to which it has to be taken. Because you are having a three-dimensional model and each building element has all the information tagged to it, by just clicking you will know what is the weight of the section which is going to come. You can plan accordingly the plant and equipment which you will be needing for erecting those elements. And lastly, enhance worker safety. So enhance worker safety by giving us earlier identification of risk. Because you have the information of all building elements, you can identify risks beforehand and visualize them and plan the works accordingly and be safe. I think I've done justice to the topics of building information modeling and 3D printing of concrete. So that's it from my end. And now my friend and colleague, Mr. Navaneeth, will be carrying on forward. Thank you.
So good evening, everyone, and thank you, Kailash, for briefing them over 3D printing and BIM. So welcome you all again for today's session, the advancements in concrete construction industry. So next, I will just give you a brief on my career. So I did my bachelor's from Amrita School of Engineering, Coimbatore in civil engineering, and I'm from the batch of 2019. Then through campus placements, I got into L&T construction. I was working as a senior engineer in operations department of wastewater business unit. And currently I'm doing my MTech in construction technology and management at NIT Surathkal. So that is through L&T sponsorship program, Build India Scholarship. Now I will just give you a brief overview over the field of construction. Like when you hear the word construction, most of you will be like thinking of the buildings and the bridges, but actually the field of construction is very vast, and it deals with so many other things, like you take railways, highways, the power transmission, and building power plants, and collecting and treating wastewater, distributing water. So it has a vast scope, and it is not just buildings and roads. So it has so many things, and as you all are aware, the field of construction contributes to the major share of the country's GDP. That is more than 10%. And as the population increases, the infrastructure development needs to be concentrated, like for easing of the living. Then that is why people say construction is an evergreen field. Now, as I'm from the background of water and effluent treatment, I'll just brief you like what are all the divisions in the water and effluent treatment. Like one major division is the large water systems, where it deals with the large projects, which that is handling a huge quantum of water, like supply of water to the irrigation, and building barrage, like that is the stopping of water for supplying it to the irrigation. Then other department is the water supply. Water supply is where we supply water to the all the households, that is collecting it from water body, and then treating it to a state where it can be consumable. Then next is wastewater. In wastewater, we have the collection of wastewater and treatment of the wastewater. Since we cannot discharge the what wastewater which is collected from households directly into the water bodies, which will create pollution, we treat it in a sewage treatment plant and then discharge it into the water bodies. Then next is the industrial effluent treatment plants, where we treat all these effluents which are released from industries. So these are the divisions we have in the water business. Then I will just give an introduction to the trends in the construction industry. So as Kailash has given you a brief idea over the building information modeling, Building information modeling is actually a like growing trend. Like all the major bigger companies are adopting to the building information modeling, as it is very much useful in the collaboration, and it is like it is more efficient. You can save cost and time as well. And modular construction is another topic where like you might have seen these large structures of the bridges lying on the roads. Those are kind of precast structures, you say. Like you don't cast it on the site, you just cast it on an ad and just bring it and place it on in place. What happens is you get more quality, and you can save more formwork. Formwork is nothing but a supporting structure or a temporary structure which you place it till then the concrete attains its strength. So when you are using this precast members, you can like it will be in the ground, so you can examine the quality, and you can maintain the standards, and you can be sure about the strength of the structures. Then uh, yeah, in the recent times, during the COVID peak, you might have got heard about this. Like the construction of a 1,000-bedded hospital in Wuhan was completed in just 9 days. That was using the prefab technology. So prefab technology is one of the very much growing technology, and which is known to be the future. And another important one is the sustainable construction. As many of you would have come across the terms like eco-friendly, conservation of resources. Similarly, in construction industry, the clients are more concentrating on the sustainable structures, as even in many of the countries, the approvals are given only if the structure is structure gets like structure is sustainable. Then another one is the 3D printing, which Kailash has briefed over to you. And next one is the VR. VR is the virtual reality. Like most of the clients, like the end users, want to visualize the project before it is being constructed. And it also helps in rectification of the errors or corrections in before in hand, like before the structure is constructed. So you can save cost and time over there. And next one is robots in construction. Like every other industry, even in construction, we are like more and more robots are being adopted, so that we can reduce the manual work, and it is more efficient also. Uh, Now I will just uh, show you some of the initiatives which we have taken up for our own sewerage treatment plant project. So here we have to construct the walls of the large tanks which have to store the wastewater, and where the treatment process takes place. So what happens is, normally in the conventional method, you have to keep the whole like formwork for the whole structure, and then pour the concrete. Formwork, as I told you earlier, it is the temporary structure to hold the concrete, and until the concrete attains a strength to hold, like to set on the position on itself. So what happens is, when you're using homework for the whole structure, it costs you more, and the time for fixing the formwork also is more. So we propose this method, that is linear moving rail formwork, wherein you have a moving rail and a formwork attached to it, and as the as one part of the structure is completed, then the rail, like the formwork is moved using the rail, and then consecutive parts are constructed. So wherein you can save both the time and cost. And next one is the pneumatic formwork. uh, like pneumatic formwork is nothing but this can be used for the drains you can see everywhere, like even outside your houses you can see the sewerage drains which are going. So and you might have seen the top caps which are constructed of concrete placed over the drains. Normally the conventional method of placing these lids for these drains is done like you have to place it in a casting yard, and these lids are casted, then it is transported and placed in these locations. What For reducing the transportation cost, what we can do is using this foam, like this pneumatic foam can be pneumatic tubes can be placed in the drains, and over these drains, like over this pneumatic tubes, we can place a frame and we can cast it in the same site, so we can save like the transportation cost here. And another one is the plastering machine. Plastering is nothing but after you construct the walls out of the bricks and the mortar, you have to give a finish. Like if you see your walls in the houses, it will be a smooth finish. For giving the smooth finish, you have to plaster it. Plaster is nothing but using the mortar. Mortar is constituting of the sand and cement. So when not conventionally, you like using this trowel, you just uh, put it over the walls. So this is done by the manual labors. So what happens is this takes a lot of time. For covering a wall, it takes a day. So using this plastering machine, this can be done in an hour or something. So, and what you can another thing is you can get the even thickness all over the walls. So this is another thing. Then this is the waste trouble pressure. The project which we executed was rehabilitation work. Like we have to demolish the existing structure and construct a new structure. So using this rubble crusher, what we did is we crushed the demolished structures and we used it as a backfill. Like we normally excavate the earth and we backfill it for getting strength. So we did not waste the material which we demolished, and this is one of the sustainable feature. And another one is the wall painting robots. Rather than painting it conventionally, we proposed for using the painting robots. Another one is the improvised digest shell construction. It is nothing but for the construction of the dome. Normally, in the conventional method, we have to take the formwork from the bottom of the structure to the top of the structure, which costs you more and the time also is more. So we proposed for placing it using this, like the shell will be precasted in the yard, and using a crane, we can place it over the top. So this saved more time. Then this is a video just to show you uh, how this plastic machine works. Like this. This is the video from our own site. As you can see, normally if it is done manually, it will take so much time, and within hours we can just finish the job. Then this is also kind of used for the plastering work, like a cement spreader tool. Normally the motor is placed between the bricks using the manual labor, but this spreading tool will help them in placing the motor like in a even shape. Here it is a video. So the size shape can be. You need not have to even it in manual. Next, as I said, the waste trouble crusher. These are some of the features of that. And here is a video. As you can see, the demolished bricks are here. Using this, we can just get it into fine grade, which can be used for backfilling.
Done.
Then this is the video on the painting robot.
Done. Introducing Walt, our robotic painting assistant that can paint 30x faster, enabling you to stay ahead of the market by months. This modular robot is easy to set up and use. It has a top speed of 60 square feet per minute, increasing the average output of a 3-painter team 10 times over. But that's just the beginning. Walt not only takes care of paint, but handles primer and putty just as well. Painters can control it with ease using our Android app. It is a plug-and-play mechanical system programmed with an intuitive graphic interface. What makes Walt really awesome is that it's smart. It can automatically paint a wall while precisely cutting off at windows, switchboards, and other non-paintable elements on its way. It remains parallel to the wall by correcting itself for any physical perturbations. Walt always sprays at a constant speed and from a constant distance, which gives the most consistent and smooth.
Then these are some of the features of the pneumatic formwork. It is made of vulcanized rubber, and you can get it according to whatever profile, like the cross-sectional profile you want. This is animation showing how that works. Like you place the uh, deflated pneumatic form tube inside the drain, then you inflate it, then you place a plywood over it. After that, you place the frame into which you are going to pour the concrete. Then you place the rebars into it. You fill it with the concrete. Then when you deflate the tube again, the tube and the uh, plywood can be removed. And later, when you remove the frame, you can you get all these covers placed over the drains without any this in transportation difficulty in transportation. Then I will get you into the topic which it's like iconic initiative which was undertaken by us, that is the dust to dawn construction. Before I get into it, I will just say, like, as the field of construction deals with the projects which have huge value, the clients want who invest in these projects want to take the returns at the earliest. So what happens is there is scope for so many new technologies, uh, which is increasing, and at the same time we have to take care of the quality and safety. So I say there is a huge scope of technology in construction industry. So, as you, if you are willing to join into construction field, you just have to get knowledge about the new technologies, and you have to learn new softwares or technologies, uh, to stay ahead of others. So I'll just get you into this dusted on construction. Basically, the problem which we face in the normal projects in India is the time overrun. Normally, construction project is of a duration of 2 to 4 years. But what happens is, as per the statistics, the projects have a time overrun. Like the projects get delayed on an average by 29 months, which is more than 2 years. So when a project of 2 years is getting delayed by 2 years, so that is that give you have to spend more cost and more time. So that is a major issue. And one more thing is the both are interdependent. When the time is going overrun, then the cost obviously is more because you have to spend on the labor, the machinery, whichever you have got. So another thing is the unrestored roads. Normally, you would have seen in your localities itself, people dig the roads for different purposes, like laying the cable, laying the pipes, and they leave it unrestored for so many months. So what happens is This again gives inconvenience and it creates threat to the public. Like it causes accidents and there are even fatalities due to these unrestored roads. So the solution which we like approach like for getting solving these problems is using this methodology. So in this methodology, the problems which you face is the traffic congestion. Like for doing the normal pipe laying work, if the traffic congestion is more, we cannot carry out our works freely. So that was one of the issue. And another one is working in depth. Like normally laying pipes, we excavate, that is, dig up the ground and we lay the pipes. And what happens in this is we have to support the soil on both the sides using the shoring, or else in, most of the terrains it is fine, but in some terrains of like places like which are near to sea, the water level will be on a higher side. So there are more chances of the soil falling into the pits. So that has to be taken care. And one more thing is the existing utilities. So many pipes and so many underground cables will be going uh, on the roads. So that has not to be disturbed while laying our pipes. So that was one of the other problem. And water table, as I said, near the ocean, the cities near the ocean, the water table will be on a higher side, and water seeps into the pits. So that has to be dewatered. Then we have to lay the pipes. So these are some of the problems. And the approach methodology which we use is like planning how the like first of initially mapping how we are going to proceed with the work. So these are the barricades. As you can see, these are the barricades and these are the excavators moving along the road, and they are excavating the like digging above the soil, and as per the plan. And next we place the manholes using these lifters, and using this lifting arrangement we place the manholes in position. Then we pour water into it and hydro test it. Then we lay the pipes and we again hydro test it using filling the water. Then after which we again backfill the soil and compact it using the rollers, and we lay the road. This is the normal procedure which we use for the pipe laying works. And what are the this thing solutions we took is initially digging a trial pit so that we can know how the soil strata is, and we can get to know what are all the barrication technology that can be used for stopping the soil from falling in. And next, the earmarking of the electric cable, like that is nothing but knowing where the cable is running, and we can plan our plan where we can dig according to that. And next is using these technology like cable detectors. We found where we can where the other utilities like water line or the cables are going. So according to which we can plan our location of excavation. And normally the pipes are joined using the electrofusion. So what happens is it takes some time for fitting the pipes, and there might be leaks. So this is a kind of technology where we use a joint wherein you insert both the pipes and you just tight it. So that saved us a time, and it was more quality wise also it was good. And this is some of the statistics how much we have executed using this initiative. And other solutions which we used is the coveralls, which for the safety of the workmen, since they are working in the night time. So the coveralls which had the reflectors were used.
Kiran, is it a network issue from Navaneeth's side? Sorry all, we are facing a network issue. So I would like to end the session. Thank you. We are sorry that we are facing a network issue. So we will be ending the session now. Thank you so much, Navneet, and thank you so much, Kailash, for a very informative session. I'm sure that the students had a really good time. We are sorry that we had to end it in the middle. So thank you all. Thank you all for watching us. And before we end the session, Kailash is here. So we would like to hear how your life at Amrita was and how it helped you to reach this point in your life. So we would like to hear that from you.
Yeah, ma'am. Thank you. As I said earlier, and the start of my presentation, I told like Amrita was instrumental in making me as a responsible engineer from a class 12 student to serve the society, right? So coming to Amrita as in the academic point of view, all the professors are of high standard and quality who have done their undergraduation, post-graduation, or have done their PhDs from great universities in India or from abroad. Many of them have done their PhDs in IIScs and IITs. So always the standard of education is high. And coming, because now I'm currently doing my MTech in NIT Trichy. So this opportunity, for getting this opportunity through L&T, we need to attend an exam, which is aptitude, and then we have a round of interview where we had a panel which consisted of professors from NIT, IIT, and a professional from L&T. It's also 4-member panel. So what they focused on was the fundamentals. So even without any preparation, though I was working, even without any preparation, I was able to answer the fundamental questions which they asked in the interview. I think that was because of the fundamental which I gained from the education experience in Amrita.
Really happy to hear that. So, Navneet, would you like to share your experience at Amrita and how it has helped you in your career?
Yes, ma'am. So Amrita actually like gave me this opportunity of getting into L&T itself, and as you can see, like Amrita actually concentrates on the new technologies and the as per the field, like how the field is going. Amrita like is changing its curriculum according to it, and we had a course of on this BIM, which helped us while getting into L&T, and even after getting into L&T. Like most of the people aren't aware of the BIM, like we were aware of it, and it helped us like giving our like sharing our knowledge to others, and like even the lab sessions helped us a lot, like for understanding all the concepts which we learn in the classes. Like none of the experiments were skipped, and one good thing about civil engineering is you can visualize everything. Like unlike other fields of engineering, you can visualize all the things whichever you learn in the books.
Really happy to hear that Amrita has helped you, both of you, through your journey. So thank you so much for joining us today and for a very wonderful session. So yeah, thank you so much. Thank you all for watching. We'll see you all for last day of Great Amrita Alumni Conclave tomorrow. The last session will be at 10 a.m. tomorrow. So we'll see you all then. Thank you.
Thank you, ma'am.